So we continue with our lecture on limiting factor. This time we are looking at a situation where you've got more than one constraint. We've been looking at where you've got one constraint. With one constraint, you rank your products and allocate your limited resources according to contribution per limiting factor. Where there's more than one constraint or one limiting factor, we cannot use the ranking as per contribution per limiting factor. Instead, we use linear programming using graphical analysis and simultaneous equation. Under this method, there are 5 steps. You formulate the model by first defining the variables. After you have defined the variables, you then establish the constraints. These constraints will generally be in the form of amount of resources used, which will be less than what is available. Remember, we say the constraint is anything which will limit your potential to maximize your objective. After you've established the constraints, you formulate your objective function. The objective function could either be to maximize profits or to minimize costs. Once you have formulated your objective function, then you solve the problem on the graph. Before the computer-based exams were introduced, you were actually required to plot the constraint on a graph. But now, since the exam is computer-based, they will give you the graph itself. Then they will require you to name the graph, to name some numbers or letters which they put on the graph, or rather to label the letters which will be given on the graph. Once the graph has been plotted, then you identify the feasible region. Under computer-based, you have to label the feasible region. So you have to pick out which one is the feasible region on the graph. So we're going to practice that in a question. You also be required to plot the slope of the objective function, which is done by the isoline. So when you've drawn your isoline on the graph, to determine the optimal point, you put a ruler on the isoline and slide the ruler away from the origin. The point at which the isoline or the ruler, as you slide it to your right side, where it leaves the feasible region, that is the point at which the objective function or the objective points will be found. So the last thing you do is to calculate the value of the objective function at the optimal point. The optimal point, again, you find them by sliding the ruler away from the left side towards the right side until you reach a point where the isoline leaves the last point where it leaves the objective function. So let's quickly look at that question 3 there. So KG Limited makes 2 products, the purse and the handbag. Each purse earns $5 contribution and each handbag earns $6. You've got the inputs there, which are the leather, the cotton, the skilled labor. We are told there are 6 skilled laborers, each working a 35-hour week, and it is not possible to recruit any additional skilled labor in the short term. So we know that skilled labor is a constraint or a limiting factor. Delivery contracts limit the amount of leather available to 600 square meters and the amount of cotton for the product lining to 375 square meters each week. So again, leather and cotton are a limiting factor. Sales forecasts have revealed that the maximum demand for purses during the period is $250. Leather costs $8 per square meter, cotton costs $1.50 per square meter, and wages are paid at $4.20 per hour. You are required, using the graphical linear programming, to determine the optimal production plan for KG Limited and calculate accurately the contribution that can be achieved using whichever equation you need. So we've said the first thing we do is to define the variables. Our variables are the purse and the handbags. So for the purse, we are going to use P. So say let P equals the weekly number of purses. Then let H equals the weekly number of handbags. So those are your variables. Next, you establish the constraints. We've got leather, which we know is limited, cotton is limited, the skilled labor are limited. So the leather, that's our constraint. 1.5 square meters is required for the purse. So you say 1.5 P plus 2H is less than 600 square meters. Which is that one there. Then the labor is given in minutes here. The P5 examiners, PM examiners, they like this kind of mismatch. You need to always pay attention to it. So here you are given minutes, but the labor itself you are given in hours. So you need to change the minutes to hours or the hours to minutes. If you change the minutes to hours, 45 minutes becomes 0.75 hours, 30 minutes becomes 0.5, there are 35 hours per week, and each laborer is working. So we've got 6 laborers times 35. So a constraint is formulated as 0.75 P plus 0.5 H is less than 210. The cotton is 1 and 1. The cotton is 375. So P plus H is less than 375. Then the demand for the pieces, we are told the demand, maximum demand is 250. So demand for the pieces is less or equal to 250. Then you always have the non-negativities. The non-negativities will not be given in the question. The non-negativities is that you cannot produce less than 0 pieces and you cannot produce less than 0 handbags. So P and H should always be greater than or equal to 0. Our objective function that's our objective function there. Each piece earns 0.5 contribution and each handbag earns $6 contribution. So our objective function is to maximize our contribution. So maximize 5P plus 6H. So we've gone up to there, up to objective function. So we now get all of these constraints and plot them on a graph. But like we said, under computer-based exams, the graph will be plotted for you. So that is our graph. So you have a graph like this in the exams. You have to label it. So that is our demand there. So after labeling, that's what you get. You've got your handbags on the H axis and your pieces on the Y. They left out a P there. You should have a P this side for the pieces, H this side for the handbags. The isoline, that's your isoline there, is drawn within. So that is your isoline. Your feasible region is this region here where I'm passing my cursor. The region which is surrounded by the constraints, where each constraint cuts. So in the exam you'll be required to label that feasible region. Okay, that is your feasible region where I'm touching, those points I'm touching make up your feasible region. So the whole of this area here is the feasible region. The isoline should be drawn within the feasible region. The isoline, you draw it from the objective function, which is to maximize our contribution. So you plot that, then you put a ruler here on the isoline, then you slide your ruler all the way up to this last point where the isoline leaves, or the ruler leaves, the feasible region. Okay? They've approximated your handbags as 180, so you come down here. So this point where it drops to the handbags, that's 180. And then to the pieces, 160. You can then substitute 160 pieces times 5, 180 handbags times 6 in the objective function, and find your contribution as $1,880 per week. Any question before we proceed?
I'm still on the optimal production. The handbag.
Yes. I didn't hear the question. Repeat.
How did we find the optimal production?
You slide the isoline, so you put a ruler on the isoline and slide it all the way up to the last point where the isoline or the ruler leaves the feasible region, which is this point where the cursor is. Then from here you drop a line to here. So it's approximately 180 if you come down here. Then if you go this way, it's approximately 160.
Sorry, are we just supposed to, like, okay, how are you sure that it's 180? Like, why isn't it 170 or something?
The graphs you'll be given, you know how a graph paper looks like?
Yes.
Yeah. The graph paper, your graph paper will be like that. So if your graph paper, you have to establish, if you've got 100 there and 200 here, you count the number of boxes. So these boxes, they've got what? 110, 120, 130, 1, 2, 3, 4, 5. So you've got 100 there. Divide by 5. So it means each box is what? 20? Right?
Yeah. Yes.
120, 140, 160, 180, 200. So your graph will be like that. So you should be able to determine where the point is standing. They've not just included the boxes in here. Clear?
Thank you.
Any other question?
So there's no range for estimation. You just have to be spot on accurate. Otherwise the answer is no.
No. There's room for rounding off. The examiner knows that you cannot be 100% accurate, but they'll look at how close are you to the very answer that they have in their marking key. As long as you are as close as possible, you should get 4 marks. Okay, if there is no question, we proceed. We move to the last part. The resources that you have may be fully used up, or they may not be fully used up. So slack occurs when the maximum available of a resource is not used. So if after taking into account the demands and the limiting factors, not all of the resources of what you thought was a limiting factor has not been utilized, then that amount which has not been utilized is known as slack. On the other hand, if the entire resource available is required for the optimal solution, then the company will be willing to pay a premium or a shadow price to obtain additional resources. So you should be able to explain what slack is and what shadow price is, and you should be able to calculate both the slack and the shadow price. So using the same question, what are the shadow prices for leather, cotton, and labor for kg? So you have to compute for each one individually. We'll start with labor. So if one more unit of labor is made available, our labor, we said the maximum we had was 600. So you add 1 to the 600, all else remaining equal. So you now have 1.5 P plus 2H equals 601. Your simultaneous equations which you did in high school. So okay. So you multiply everything in the labor by 2. 2 times 0.75 gives you 1.75p. 0.5 times 2 gives you 1. 210 times 2 gives you 420. So you've got 1.5p here minus 1.5p. This cancel out. You've got 2h minus 1h cancels out to give you h. Then 601 minus 420 gives you 181. So our H is 181. So you can now substitute your H in there. So 181 times 2 gives you 362. So we've got 1.5p plus 362 equals 601. So you can make p the subject to the formula. So p becomes 159.33. So you have H that and P that. So you can now substitute those in the objective function. To give you your contribution of 1882.65. You compare that with your original contribution. So your answer is 265. Any question? If there's no question, we move. So that is our shadow price. Our shadow price is 2.65. So the shadow price, you add it to the usual price. So that's the maximum which KG will be willing to pay for the leather. We move to the labor. So 2.65 is the maximum extra KG Limited to be prepared to pay to obtain one further square meter of leather. So the maximum price it would pay is therefore 10.65 for 1 square meter of leather. We move to labor. Again, you do the same thing. Labor, we are at 210. So you add one more labor. You go through again your simultaneous equation. Again, they multiplied everything there by 2. They multiplied everything by 2 so that they can cancel the P. We've got 1H here, so 2H minus 1H gives us H. 600 minus 422 gives us 178. So our H is 178. You substitute the 178 for H there. Make P the subject to the formula. So our P is 162.67. So you have your optimal production there, 178 handbags, 162.67 pesos. Substitute in the objective function, you get 1881.35. Subtract from your original contribution, you get your shadow price of 1.35. You add that to the usual price again. These are the prices here. The labor 8, leather 8 rather, the wages 4.20. So 4.20 plus the shadow price gives you the maximum. So 1.35 is the maximum extra KG Limited would be prepared to pay to obtain one further hour of labor. So the maximum price it would pay would therefore be 5.55. Did we utilize all the cotton? Did we utilize all the cotton? The amount of cotton available was 375. We need 1 square meter and 1 square meter. 1 times 180 gives us 180, and 1 times 160 gives us 160. 160 plus 180 gives us 340. We have 375 square meters. So cotton is not a limiting factor. We've got more than enough for us to maximize our objective. So therefore, the shadow price of cotton is 0, since it is not a binding constraint. Therefore, the shadow price of cotton is 0, since it is not a binding constraint. So that concludes limiting factor with more than one constraint using linear programming. Any question? Okay, if there's no question, please prepare for homework in this area. I'll be sending some homework. Thank you very much. Have a good day.